So what we're going to do here is see how buying Halloween candy can help us to understand why the standard deviation is a good number to understand the spread of data. So let's say you live in a neighborhood where you expect 100 kids to come to your house for Halloween. Okay, so you want to make sure you have 100 candy bars to hand out to the kids. And that if you don't have 100 candy bars, you're going to have some screaming kids on your porch. So you go to your Walmart, and they have a box of candy from a manufacturer. And let's say the production run is 1,000 boxes of candy, okay? And they have done quality control. And so they have found that every single one of those 1,000 boxes has exactly 100 pieces of candy inside of it. Okay? So we see that every single one of those boxes is right here at 100. So the standard deviation is 0. Okay? There's absolutely no variation here. Everyone has exactly 100. Okay? And so the price of that is going to be $20. Okay? So we think, okay, well, I'll pay $20. That way I'm making sure every kid is going to be happy. Okay, next to it, though, they've got a box from another manufacturer that has a different level of quality control. So in their case, you can see that there's a different distribution that we see in red. So some of these boxes probably only have about 90. Some might have more. Okay? And so the standard deviation is small, so it's bigger than 0, but it's still not very big. And so the price is a bit cheaper. And so you might think, well, I think 100 kids will come, and so probably, I have a really good chance that I'll get at least 95 or so, and there's a good chance I might have even more than 100. So I'll go ahead and get that. But then there's another box of candy from a different manufacturer. This is in blue. And so we see that they have pretty sloppy quality control. So some of their boxes have 80, some have 120. Okay? So we see they have a big standard deviation. The price is cheaper. Okay? So you sort of have to decide, okay, is it really important to me to have exactly 100, very small standard deviation? Am I willing to pay that extra price? Do I have some wiggle room? It doesn't matter too much if it's just real close, but not exactly. Or is it okay that we have a big standard deviation and there's a good chance that I'll have a lot fewer or a lot smaller? Okay, so this is not the math of standard deviations, but hopefully you can see here conceptually why it's important.